Welcome to Converging Dialogues. This is Xavier Bonilla. On this episode, I'm speaking with the very wonderful and very brilliant Daniel Lieberman. Dan is a professor in the Department of Human Evolutionary Biology and the Edwin M. Lerner II Professor of Biological Sciences at Harvard University. He's also a member of the Department of Organismic and Evolutionary Biology. He has degrees from Harvard and Cambridge, and much of his research focuses on the human body, how it is, why it is, how it's evolved, and how we can understand human evolution for many of the facets of contemporary health. He's the author of two popular science books, which are The Story of the Human Body and Exercised, Why Something We Never Evolved to Do is Healthy and Rewarding, which is one of the best books I read last year. We spend much of the conversation talking about his book, Exercised, although there are bits of the previous book, The Story of the Human Body, that we touch on. We start by talking just briefly about evolution and adaptation and how that's important as a kind of framework to understand the evolution of the human body. We talk about how we use energy just within our bodies. We talk about some of the myths of sitting, how much we should sleep, why speed and endurance are important for humans. We talk about proactive and reactive aggression, the importance of walking and running. We talk about the active grandparent hypothesis and what he means by that. And towards the end, he gives a nice bit on how understanding the body can help us more understand of how we can fight diseases, and kind of gives a relevant bit on what COVID is doing to the human body and some of his thoughts on that. Dan is well published. He's a brilliant researcher. He writes very well, and he has really, really fantastic books. And I would say his book, Exercised, is a very, very important book. I think that everyone should really read because of how there's so many ways in which we have these myths about sitting and running and exercise and how much we need and how much we shouldn't. And his book does a really nice job of kind of debunking some of those myths and giving some really salient information from an evolutionary perspective. And so now I bring you Daniel Lieberman. I'm here with Daniel Lieberman. Dan, thanks so much for coming on the podcast. I'm very excited to talk to you about your wonderful research and your great books. So thanks for coming on.
My pleasure. Thanks for asking me.
Yeah, of course. So before I tell folks about your books, just tell the listeners who you are and what you do and what your research is usually involved in.
So my name is Dan Lieberman. I'm a professor of human evolutionary biology at Harvard University. And my research is really on how and why the human body is the way it is, with a focus on the evolution of human physical activity. So I study, I'm most famous for my work on running, but I've also studied walking and throwing and chewing and sitting and, all kinds of other physical activities. Mm-hmm. But I'm also very interested in how that relates to health. So because I'm interested in the role that our evolutionary history as physically active and also inactive creatures is relevant to health and disease in general, and I'm also interested in sort of other aspects of how evolutionary theory and data can be applied to the topics of health and disease.
Mm-hmm. Yeah. Well, you've written two wonderful popular science books. The first is The Story of the Human Body, Evolution, Health, and Disease, and this is in softback now, or paperback, I guess you say. And the more recent one, which came out last year, it's come out last year, maybe it was 2 years ago.
Yeah, it came out just about a year ago.
Yeah, it's called Exercised. That's a nice play on words. Why Something We Never Evolved to Do is Healthy and Rewarding. That was one of the best books I read that came out last year. It was really, really, really good, really eye-opening in a lot of ways. So both of those are fantastic, and we'll get right into it. Most of the questions I have and things I want to discuss is from the most recent book, Exercise. Although I did notice there's a lot of overlap or not a lot, but there's some overlap from the first book. So that would be cool to kind of tie in some of that. I guess the first question I have is as a general and broad question, how, and again, this is a big one, but just kind of give us the the brief overview of it, how does natural selection and adaptation in general, in terms of that framework, how does that help us understand how the history of the human body evolves, right? That's a big question, but just kind of give us the overview.
Well, I mean, very simply, natural selection leads to adaptations, right? So natural selection is the process by which the emergent process that results from three things, right? You have variation, heritability, and differential reproductive success, right? So there's lots of variation out there among, all living organisms. Humans are no exception. Mm-hmm. Some of that variation has a heritable basis because of genes, and because of that variation, some of us heritable variation, some individuals have more offspring who survive and reproduce, and the end result of that is natural selection, whether you like it or not. And what natural selection tends to promote or favor is adaptations. These are aspects of our phenotype or that are selected that improve reproductive success. Ultimately, improve reproductive success, and it can do that directly or sometimes indirectly. And so, if you want to understand what we're adapted for, right, you need to take an evolutionary perspective, because an evolutionary perspective explains the adaptations of our bodies and how and why they work the way they do or don't work the way they do, and what happens when you, for example, remove an individual from the environment for which they're adapted, and that leads to a variety of diseases, which we call mismatched diseases. So mismatched diseases are diseases that are more common or more severe because our bodies are inadequately or imperfectly adapted to novel environmental conditions. So if you want to understand, why we are the way we are and why we get sick, and also what we can do to prevent us from getting sick, or even in some cases treating illness and other diseases, you need to understand. You need to think about adaptations. I'll give you a very simple example, right? Sure. One that's common to a lot of people around the planet. And that is the way people struggle to diet. Right? There are, 2/3 of Americans are overweight or obese, and a lot of them are regularly trying to figure out ways to lose weight. And what happens is when you lose weight, you turn on an adaptive response called a famine response. Your cortisol levels go up. It makes you crave food. It makes you less. Your energy levels go down. You stop being as active as you might otherwise be, et cetera. And the end result is that it's really, really hard to stay in that negative energy balance state because of this ancient adaptation, the famine response. And then we tell people, just suck it up, right? But we're not adapted to do that. We never evolved to lose weight, and that doesn't mean you can't lose weight. You can, but it's hard, and we need to understand that adaptive response in order to help people.
Yeah, I think that's one of the things that's so interesting about your book is in the 4 sections, and then I think it's over a couple to 12 chapters or something. You kind of go through these myths, right? You kind of alluding to one of them, and one of the first myths is that we're evolved to exercise. And your book kind of outlines it, says, well, wait a minute, not exactly. And the first part of your book is all about inactivity. Which was a really interesting place to kind of start. And in the beginning, you talk about these different people groups that are, around the world. So what can they tell us? Different tribes around the world tell us about the evolutionary history of being active or being sedentary. What can that, inform us?
Well, the sad fact of the matter is that the vast majority of data that we have about human beings comes from a very tiny sliver of humanity. What my colleague Joe Henrich calls weird people, Western, educated, industrialized, rich, and democratic, weird. Right. And weird people actually account for about 9 or 10% of the planet at the moment. And yet they account for, Mike Irvin and I did a study where we showed that about more than 80% of the data published in major medical journals comes from weird populations. So almost all that we know and think about human beings comes from a very odd and unusual slice of humanity, not only by today's standards, but by evolutionary standards, because until recently nobody was like you or me. And so if we want to understand how humans are adapted, what we're adapted to do, we can't just study college students at universities in the United States or Sweden or whatever. Right. We need to go look at people in other parts of the world, and that's what we do. So in my lab, we do research on college students at Harvard, but we also take the lab out into the field. And one place that we've been doing work for a long time is in Western Kenya, where we've been working with farmers, subsistence farmers who basically don't have roads and electricity and running water and machines, and they do all their labor by hand. And then we can study what happens to the people from that same population who move to the nearby city of Eldoret, where they live like people in Boston for the most part. Mm-hmm. So and also we've done that in other parts of the world, and also I draw on data. And of course, my own observations, so I have not collected data on hunter-gatherers in Tanzania, for example, the Hadza, which are tiny little population that are every anthropologist and who can gets down there to study them. So they're now it's like a resource for the Hadza anthropologists who study them. But nonetheless, they're a kind of a window. It's not a perfect window, but they give us some information about what hunter-gatherers are like. And then, of course, there's lots of ethnographic data from other parts of the world and other hunter-gatherer populations. And if you put all that data together, you get some sense of what the ranges of environments and the kinds of physical activities and the kinds of diets and what have you that people used to engage in.
I think you mentioned the Hadza that there's sedentary group, right? And there's other groups that are also sedentary. How do we understand when you're talking about broadening this scope, right? So not just looking at weird people, but looking at people around the world, and you see that there's some groups that are sedentary. They're not necessarily running marathons and they're not necessarily doing all these things. They are sedentary. You talk about it in the book, but how does that fit in with understanding how we can be active?
Well, the Hadza are not sedentary.
No, they're not sedentary. Excuse me.
By any stretch of the imagination, they're pretty hardworking. Mm-hmm. Dave Reichlin and Herman Panzer and Brian Wood and others who've put heart rate monitors and GPSs on the Hadza show that the Hadza on a typical day will spend about 2 to 3 hours a day in moderate to vigorous physical activity. So that's like a brisk walk or more. Now they're not crazy physically active. It's not like the Tour de France athletes, right? They're not these super athletes running marathons or whatever, but they're working reasonably hard, as do farmers, subsistence farmers, the people who we study in Kenya, who work about the same or a little harder. But they're also, when they're not working really hard, they do just what Westerners do. They sit. And so, we hear that, sitting is the new smoking. And it's one of the myths in the book that I enjoy, poking fun at because I think there's this idea, I call it the myth of the athletic savage, that our ancestors were these incredible, super bulked, incredible, athletes who could get out of bed and run ultra marathons and hoisted giant rocks over their heads. And, it's called the primal fitness movement. There are people who have the kind of a cartoon-like sort of picture in their minds of what our cavemen ancestors were like. We weren't like that. But so the Hadza and other groups that have been studied are moderately physically active. They also spend a fair amount of time doing light chores, but they also sit 9-10 hours a day. Although they do sit a little bit differently than we do. They don't sit in chairs, and they get up a lot rather than sit for long, uninterrupted bouts. And that turns out to be an important health effect. But they're not crazy active. They're just moderately active. So to put that into perspective, the average American maybe spends about 20 minutes a day in moderate to vigorous physical activity. So the Hadza are 6 to 10 times more active than your average American. And another difference is that your average American, as they get older, becomes less active. The Hadza also become a little bit less active as they age, but nothing like Americans. So that difference becomes increasingly great as people age.
Yeah, I think that's what's important, right? And I think that's the through line in your book, which is, how do we have active lifestyles, right? Where we're able to increase activity, not necessarily excessive amounts of exercise per se, right? But, how do we have more active lifestyles, which, is, I think, difficult for a lot of folks for various reasons. You mentioned in this part about how we're still spending energy even when we're resting, right? And that you talk about these importance of trade-offs. Could you just explain that? That was a little counterintuitive to me for when I first read it. And I said, how does that work? How are we still spending the energy? You talk about resting metabolic rate and things like that. So kind of explain to us how that works.
So every day you spend a certain amount of energy, right? Energy goes in, and you spend it, right? You eat the energy in the form of food, and then you do stuff, right? And we tend to think of the way we spend energy like, well, I went for a run this morning and I spent a fair amount of energy. I probably spent 500-600 calories running this morning. And maybe I spent some energy fidgeting and gesticulating and all that kind of stuff. And I spent some energy digesting my breakfast and my lunch and whatever. But it turns out that energy, the energy you spend being active, what we call active energy expenditure, and the energy you spend on digestion and maybe thermoregulation is actually only about a third of your energy budget. About 2/3 of the energy you spend every day is just to maintain your body. We call that your basal metabolic rate under some definitions, or your resting energy expenditure. It's all, we don't want to get into the weeds of that. But basically 2 out of 3 calories that you spend are spent on functions that you can't observe or can't even feel, replacing all the blood in your body and all the cells in your gut, and keeping your brain functioning and keeping your muscles in order. And, all of that costs an enormous amount of energy. In fact, a typical adult man probably spends, 1,600-1,700 calories a day just maintaining his or her body. Now against that backdrop, you have to realize that, people also spend energy being physically active and doing other things. And so a total, daily energy budget for somebody might be, 2,600 calories a day. Let's just take that for a number. Of course, it varies, right? Sure. Now, back in the day, right? So now if I want 2,600 calories, it's easy, right? I can go down to my kitchen and there's, thousands and thousands and thousands of calories readily available to me. And if I want more, I only have to walk a few blocks to the store and there's gazillion calories in the local supermarket, right? For basically no effort. Right. But for most of human evolutionary history, people struggled to get enough calories. It was difficult. And so calories were, unless you're in a weird population, calories are a limited resource, right? They're just like time, right? The time you're spending listening to me right now is time that you will never get back. It's a very limited resource, right? Calories are also limited resources for most people and for most animals. And when a resource is limited, you have to engage in trade-offs, right? So if you spend 5 minutes listening to me, that's 5 minutes you didn't spend, doing something much more profitable, right? Like, maybe reading a book or eating dinner or something. If you spend 500 calories on a run, that's 500 calories you didn't spend on something else, like taking care of your body or what natural selection really cares about, which is reproduction. So organisms have to allocate energy from in different ways. They can spend energy on growing when they're young. They can spend energy on storing energy, right? Fat. They can spend energy on reproduction. They can spend energy on physical activity, and they can spend energy on maintaining their bodies. And the thing is that what natural selection cares about ultimately is one thing and one thing only, which is reproduction. So anytime you can save energy on one of those other functions and plow it to reproduction, you win from a selective perspective. And so we are innately adapted to not be physically active when it's not necessary or rewarding, because that energy could have and should have in past environments gone towards reproduction. So going, like this morning, I went for a 6-mile run. And for no purpose at all, just, because no real important purpose. I wasn't, hunting or gathering or whatever. I just went for a run with a friend because, for the sake of health and fitness. Had I been a hunter-gatherer struggling to get enough calories, that would have been a completely stupid thing to do. Right? Because I would have wasted 600 calories that I could spend either taking care of my body or more importantly, reproducing, which is what natural selection cares about, right? But it doesn't bother me because I can just, scarf another, donut or something and make up those calories.
Right. That's a really nice perspective in terms of the trade-offs. 2 points here on the inactivity piece of things is you talk about why sitting isn't as bad as we think it is, right? Which again is, I think, could you explain this, right? How do we understand sitting and what can we say about it and what should we not say about it? I'll say that.
Well, one of the reasons, the main reason I entitled the book Exercised is that we've made people exercised about pretty much everything to do with physical activity. We make them nervous, we make them confused, we make them feel bad about themselves. We shame and blame people all the time for their habits. And one of the ones that's been on the news a lot recently is sitting, right? We're told that sitting is the new smoking, your chair is out to kill you, et cetera, et cetera, et cetera. and as if it's like some completely bizarre modern thing that nobody ever did. And guess what? If you go around and like, I had the good fortune to travel to a lot of different places and spend time with, hunter gatherers and in Africa and hunters, Inuit in Greenland and, farmers in different countries, et cetera. And guess what? Most of the time when people aren't working, they're sitting too. Sitting is completely normal. And you know what? Go around, look at animals. They sit all the time too. My dog spends her day sitting around the house. Cows sit in fields. Birds sit. Moose sit. It's the idea that sitting is this like weird, strange, modern American thing is been exaggerated. Now, what we really want to say is that if you sit all day at work and you also sit in order to get to work, say in your car, and then you go home and then you sit on a couch all day, all evening watching TV or reading a book or whatever, and then you go to bed and basically you sit all day long and never do any physical activity, yes, then you're going to be in trouble, right? You increase your vulnerability to a wide range of diseases. And so really the problem is how much sitting people do. And you can get online and in the book, I describe how you can get any number you want from Googling how much people sit today. And most of the numbers are just made up or fabricated or exaggerated or whatever. But when you actually put sensors on people and actually measure what they do, it turns out that Americans sit a fair amount. As they get older, they tend to sit more. Some people definitely sit too much, but they don't sit. Your average American isn't sitting some crazy amount that a hunter-gatherer wouldn't do. What is most different is the way we sit, right? I'm sitting now in a chair. I'm leaning forward, but if I wanted to, I can lean back, and my chair is a nice backrest, and I don't have to use any muscles to hold up my upper body. I don't have to use any muscles on my legs, etc. But in the places I work, there are no chairs. I mean, there really are no chairs, right? People sit on the ground. They squat. And when they do that, they have to hold up their bodies. They have to use their legs a little bit. So that's one difference. And the other difference, of course, is that people get up a lot, right? I mean, if you're sitting in front of a computer or watching a movie, you might sit in a completely inert fashion for several hours. But if you're minding the fire and taking care of kids and doing little chores and whatever, you're going to get up every 10, 15 minutes, it turns out, in most of these other populations. And just getting up every once in a while is a bit like the turning on your engine of your car. It turns on your metabolism. You're not spending a lot of energy, but you're using up some sugar in your bloodstream and some fats in your bloodstream, and we don't know what else is going on, and turning on certain kinds of genes. And so it turns out that frequent interrupted sitting, even if you sit the same amount as somebody, two people can sit the same amount of time. They can sit 10 hours a day. But the person who gets up every 10, 15 minutes, to go to the bathroom and make a cup of tea and pet their dog or whatever, is going to be doing much better metabolically than the person who sits exactly the same amount of time, but without getting up at all. And so we can learn how to sit better, but let's not demonize sitting and pretend it's some strange modern Western thing that nobody ever did.
It's interesting how it sounds like these small micro moments really have is kind of a building kind of block. Is kind of this, what kind of budget do you have throughout the day? And if you have these small kind of pieces where you're doing something, getting up multiple times, and at the end of the day or at the end of the week, that all kind of adds up of sorts, which is really fascinating.
Yeah, I mean, it's not just sitting. I mean, there's different kinds of physical activity. There's the kind that I did this morning, going for a run, right? I did a bout of exercise, but most of the physical activity that people do is not exercise. There are different terms for it. The common term in the literature is NEAT, non-exercise activity thermogenesis, which is a term I don't like. I prefer non-exercise physical activity, NEPA. But anyway, the point is that for most people, that non-exercise physical activity is by far the majority of their physical activity. But your body doesn't care whether it's a run or, you're sweeping the floor or, doing errands or taking the dog for a walk or whatever, or hunting a gazelle or, running to get the bus or whatever, right? Climbing stairs. Your body doesn't care what the purpose is. The body just responds to the stimulus of the physical activity. And of course, and recently, nobody exercised, because exercise, as I define as discretionary physical activity for the sake of health and fitness. And that's a completely modern concept. A few thousand years ago, people only were physically active when they had to, because in order to get food or not be somebody else's food, or when it was rewarding for some other purpose, like, dancing to get a mate, or, for part of a ritual, or have fun, for social reasons, etc. But nobody, I mean, this morning, for example, I went for a run, right? For no reason whatsoever. And then I went down to my basement and I lifted weights. And you think about those weights. I actually bought those weights. Right? These are pieces of metal that I spent money on, whose sole purpose is for me to lift them.
Right.
And I spent a lot of money on these weights too. And they're nice weights, etc. But imagine explaining that to somebody a few thousand years ago, that you spent your hard-earned money on something, on a bunch of weights whose sole purpose was to be lifted. I mean, or explaining a treadmill to somebody, right? A machine, a noisy, horrible, nasty, loud, slightly dangerous machine that makes you work really hard to get nowhere, right? I mean, they think you are a complete idiot, right? And but now, of course, in a world where we don't have to be physically active, we've had to invent exercise because otherwise we're more likely to get sick. It's good for us.
Yeah, the perspectives of things are just absolutely fascinating, especially when you put it that way. The one last question here on the inactivity piece is about sleep. I actually hear a lot about sleep from clients that I see in clinical work and from friends and family and stuff. Is sleep is such a, I feel like it's not talked about enough, or I'm sure in some circles it is, but it's something that is also has a lot of myths around it. And many people say there's this, 8 hours of sleep and, things like that. But you kind of mentioned this in the book of, there are so many, negative things about sleep, or a lot of misinformation, I guess you could say, about there. And so what can we say about, what the purpose of, sleep is in general, but then how much should we be getting? Is this generalized or is this more individualized? Quality versus the quantity, et cetera? What can we say definitively about sleep?
Well, if you want another topic about where we make people exercise, it's definitely sleep. We make people exercised about sleep. There's a lot of money to be made by making people exercised about sleep. So there's a lot of people who's making a fortune out of this. Look, we sleep for a bunch of reasons, right? We sleep to clear out our brains. When you sleep, your brain basically pumps fluid through various spaces and gets rid of all the metabolic byproducts of all the activity that happened during the day. So as you use your brain over the day, you build up metabolites that have to be cleaned out. And we also sleep because during sleep we actually engage in sort of memory reorganization, right? We move essentially, to use an analogy, we move data from our hippocampus, which is like a USB drive, to other parts of the brain. I mean, I'm ridiculously oversimplifying, but it's not a completely unreasonable oversimplification. So we consolidate and sort and remove memories, right? So sleep, and it probably has some other functions too. So we need to sleep. But how much we sleep is argued about. And this idea that you need 8 hours of sleep is a completely modern, I think, essentially Victorian industrial concept. When people have measured sleep in populations that have no electricity, right? No phones, no iPhones, no TV, no electric lights, nothing, right? Put monitors on them. It turns out they sleep, 6.7 to I think 7.1 hours a night. I think that's the average. They often don't even nap. And they're doing just fine. And you can read in books like this book, Why We Sleep, that, oh, no, they all die young. That's actually not true. Life expectancy is a very dangerous variable to use when you're looking at hunter-gatherer health, because they have high infant mortality. But if you actually correct for infant mortality, they're living to be, 68 to 78 years of age, right? So they're not dying young from lack of sleep by any stretch of the imagination. They're doing just fine. And in fact, when you look at big epidemiological samples of Americans and Europeans, and you look at, say, for example, incidence of heart disease or mortality rates on the y-axis against how much people sleep at night on the x-axis, it's a U-shaped curve, and the bottom of the U-shaped curve is usually around 7 hours. Now, there's a lot of variation. Some people need more, some people need less. Teenagers need more, older people need less, et cetera, et cetera, et cetera. But the idea that everybody needs 8 hours of sleep is just made up. But here's the thing that's I find concerning, which is that when we tell people they need 8 hours of sleep, or that they need a certain amount of sleep, then guess what people get? They get stressed. Causes psychosocial stress. And psychosocial stress, guess what it does? It causes your cortisol levels to rise. And cortisol is a hormone that arouses you and prevents you from, guess what? Sleeping. So if you make people stressed about sleep, you are doing pretty much the best thing you can do, or one of the things you can do, to actually prevent them from sleeping, right? And then we tell them, you need to be in a quiet room with no lights and no noise, etc. that's, nice. And I like sleeping in a nice quiet room with a nice, comfortable mattress and no noise, but that's not how we evolved to sleep. And people can learn to sleep in any kind of circumstance if they're not stressed about it. People sleep on airplanes. If you can sleep on an airplane, you can sleep anywhere, right? And yet the same people who sleep on airplanes tell me that they're, having trouble sleeping. It's all contextual, right? So I think and that's not to trivialize that people who don't get enough sleep have serious troubles. They do.
Sure.
Sleep is important, and we need to help people sleep, but making them stressed about it is a terrible way to do it. And of course, one of the best ways to help you sleep is to exercise, because physical activity helps you fall asleep. There's so much. You don't even need studies to tell you that, although there are plenty of studies which clearly affirm that very strongly. So let's be more compassionate to each other and less rigid, and be more understanding, and also understand really how weird the modern world is, and take a less exercised view of sleep.
Yeah, no, I agree with you. I've heard all this chatter about sleep, and I also have read some literature that shows that, the whole 8-hour thing is kind of, just kind of an old, antiquated thing at this point, and, really is kind of context dependent, and is kind of somewhat individualized, for some people. One of the things you talk about in close to the middle of the book is about speed and strength, which is super interesting for the human body. And you mention bipedalism, right? Obviously, from our ancestors, we became bipedal. And it's not, we're not the only creatures that are bipedal, but it's a hallmark of sorts for humans in some ways. And you mentioned in your first book, and you mentioned it in this book, Exercise. And so the question I want to ask is, what is it about bipedalism that makes us slow? Aside from the obvious, right? If you have four legs on the ground.
It's pretty obvious. If you had a car with
no other mystery to it.
If you have 4 cylinders in your car, you can generate more power than if you had 2 cylinders in your car. And if you have 2 legs, you can generate half the power as you have 4 legs. It's kind of pretty simple. You could compensate like an ostrich and make those 2 legs super powerful. Right. But we have not. Evolution has not blessed us that way. So we are, we're about, you can actually calculate that we're about, we should be about half the speed. We should have about half the speed of a mammal of our body size by being bipedal. And if you actually look at the data, that's about right. Other animals like sheep that are, twice our body size can pretty much run about twice as fast as us. And I'm talking, when I say twice as fast as us, I'm talking about twice as fast as the fastest among us, right? And, we often talk about, when we talk about speed, we often talk about the world's best sprinters, elite athletes who've spent years and years and years and years and years of their life training for one distance, and never turning even a corner. They run just in a straight line, and whatever, and they're amazing, right? Like Usain Bolt, can run 10.4, 10 point something meters a second, way faster than the vast majority of human beings, including the vast majority of hunter-gatherers, who could never run that fast, right? So we're not very fast, right? But that doesn't mean that speed isn't important sometimes. Obviously it is. If the old joke, you only have to be faster than the next person, right? When a lion is chasing you, that's all that matters, right? So speed can be important sometimes in hunting and whatever, or in survival. It's important for sports and play, and which has also played a major role in our evolutionary history. But what we're clearly adapted for is endurance, and what we're really exceptional at as athletes is our endurance sports. So though a lot of the sports that we care about when we compete against other humans are sports that involve speed and strength, we're not all that strong and we're not all that fast, but we value those traits because they're important for fighting. And think about most major Olympic sports evolved, the old ones were physical activities, were skills that were important for fighting. Wrestling, we don't do chariot racing anymore, I guess, in the Olympics, but javelin throwing, wrestling, discus throwing, boxing, these are all, sprinting, right? These are all speed and strength things, and they're, fun to watch and all that. But that's not what makes us exceptional as a species. What makes us generally exceptional as a species is our endurance. And there we're exceptional. You don't have, humans can, even I have outrun horses in marathons, and I'm not an exceptional, athlete. I'm a middle-aged professor, so that's what we're really good at.
I guess the question I have with that is that obviously we have it now for play and sports and things like that. I guess what is the value, I guess, of, for hundreds of thousands of years, we needed to have speed and or endurance to, run away from things or to kill things, to animals to eat. But what is the purpose, I guess, for speed and endurance now for us in the modern age?
Well, so speed can be useful for a variety of reasons. So speed is basically generating a lot of power and going fast. And so, for example, I'm a runner and I like to run. And one of the ways in which I train is to do what's called high intensity interval training.
Mm-hmm. This is the HIIT.
So
right?
HIIT, right?
Mm-hmm.
And there are various ways of doing it. That's just the common term today. This has been around for a while. It's not a modern discovery. But what that does is it's a stress, right? So when I go to the track, for example, or do what's called fartleks, speed play is a Finnish word after Paavo Nurmi, who I think the great Finnish runner who I think invented the term. But anyway, I'll see a bench that's maybe 300 yards or 400 yards in the distance, and I'll sprint to that bench, and then I'll slow down, recover my breath, and find it. I'll see if I can get to that person in the blue hat. Mm-hmm. Sprint to that. That's a great way of, and that kind of speed training actually improves my endurance because it's stressing my system in all kinds of ways. It's making my lactate, which is a metabolite byproduct of physical activity. It's improving the enzymes that clear the lactate from my blood and my muscles that make them acidic. It makes me pant, right? So I need to improve my oxygen delivery system and maybe increase my mitochondrial density and all sorts of things. And then when I go for a long run, it actually improves my endurance. Mm-hmm. So we have this idea that speed and endurance are trade-offs, but they're actually not completely traded off. There are trade-offs in some regards, but not in other regards. So if you want to improve your endurance, one of the ways to do that is actually to work not always, but sometimes on your speed. Mm-hmm. So they're not entirely traded off. Now, strength is another issue, right? So strength, humans don't need to be super strong. We probably haven't had to be super strong for a long time. And in fact, being really strong was probably a bad idea for most of the Paleolithic, because muscle is expensive. If I bulk up and like Arnold Schwarzenegger back in the old days, right? Mm-hmm. Have all that extra muscle, I need to eat a ton more in order to pay for that extra muscle. If I don't need that muscle, it's just costing me calories that I could use for something else that would be more important.
Right. Yeah.
So you want to be strong enough to do the tasks that are important for you, mm-hmm. but you don't want to be any stronger than that, because otherwise you're costing yourself a lot of energy. And so that's why we have this use it and lose it system, right? If we use our muscles, they bulk up. If we disuse them, stop using them, they atrophy, and that's a great system, right? Mm-hmm. The problem is that as people become older and they become less physically active and their muscles start atrophying, they get what physicians call sarcopenia. Sarco is the Greek word for flesh, and penia is loss, so flesh loss. And or another way of thinking about it is they become frail. And we all have seen it, right? The person who has trouble getting out of a chair, or can't get off the toilet, or can't lift their groceries, or what have you. And when that happens, often a vicious cycle ensues, because when you become frail, you become less able to do all kinds of physical activities. It gets harder to walk, and it gets harder to do things. And then you become less physically active, which then keeps this vicious circle going. So as we get older, staying strong, reasonably strong, becomes really important for health, especially also for maintaining your stability so you don't fall. And falling is a very important issue for older people. Yeah. And it's also important for maintaining bone health, because as you use your muscles apply strength to forces to bone, and that keeps bones strong. So there's a number of reasons why some degree of strength is important. But you don't have to be ripped and go to a gym and do small weights with high repetition numbers is actually pretty much all that people need to do. And if you do it a few times a week, you don't have to do a crazy amount. You can really improve your health span and avoid frailty, which can have all kinds of dividends, especially as you age. And of course, hunter-gatherers never had any choice. Hunter-gatherers didn't have can openers and elevators and shopping carts and all those things that enable us today to basically never use our muscles very much for strength purposes. And as a result, hunter-gatherers, as they age, don't lose strength as rapidly as Westerners do.
Yeah. It's interesting is some people will become quite obsessed with just doing some type of cardio or just doing running. And it's like, well, that's important, but you also need to probably throw in the mix somewhere in there. How are you building your muscles? How are you building your bones? You got to make sure that, they are also maintained as well.
Yeah. I mean, look, you don't need a professor or physician or, trainer to tell you that it's good to mix it up. I mean, I think everybody probably knows that. It's just that some people, tend to prefer one sort of thing versus another thing. And I'm sure all of them, everybody who does just strength training probably knows somewhere in that some corner of their brain that maybe they should do some cardio. And that, the people who do only cardio would probably know somewhere in some recess of their brains as well that, a little strength training might not be actually a bad idea. But we're very good at justifying to ourselves what we like to do. And we can ultimately pay some kind of price for it. The fact of the matter is, if you look at the data, cardio is the bedrock of any physical activity program. It's by far the most important for most aspects of health. Cardiovascular health being one of them, right? Cardio is called cardio for a reason, right? It's also very important for metabolic health, and it's important for just burning calories and fighting cancer and Alzheimer's, and the list is really long. But strength training can also help for some of those things. And when you look at studies that look at particular outcomes, metabolic syndrome is one that's studied the most. Studies in which people mix it up do better than people who do just one or the other. And, it's not actually all that surprising. It makes a lot of sense because you're using different systems.
Yeah. Quick question I have here on aggression. Obviously, it's a big topic, and we don't have to go into all of it. But I do want to ask, though, about why, this kind of Wrangram's ideas of proactive versus reactive aggression, and how we have this process of humans becoming self-domesticated, as you call, contributed to making us less reactively aggressive. So maybe just tell us what those terms are, and then why we evolved to kind of become more less reactively aggressive.
So this idea doesn't come from me. It comes from my colleague, Richard Wrangham, who wrote a wonderful book called The Goodness Paradox, where he looked at different kinds of aggression because, it happens all the time. You have some person, goes out and does something horrible, shoots up a bunch of people in a school or something like that. And then, the news reporters interview their neighbor who say, "Oh, what a lovely person. I can't, how did this person do this?" Right. And it's because we often don't understand that there are different kinds of aggression. And so people can be very non-aggressive in one regard and very aggressive in other regards. And so Wrangham makes a distinction between what's called reactive aggression, which is that instinctive quick response, right? When, road rage, right? When somebody comes up to you and, blocks you off or steals a book from you or whatever, right? And you have a quick instant response. Versus proactive aggression, which is when you plan it, you think it out, right? War is an example of proactive aggression. It's premeditated and it's organized and it's thought out. And what humans are really good at is we've evolved to be very good at controlling our reactive aggression. And we do that a lot with our prefrontal cortex, part of our brain, which we know is enlarged in humans compared to chimpanzees, who are really bad at controlling their reactive aggression. But what we've done is we've become really good at proactive aggression, right? We're really good at figuring out how to really, kill other people, screw other people, be really in a kind of clever way, right? And they're totally different. And so most of the time, when somebody goes commits an atrocious act, that's actually an act of proactive aggression. They planned it, they thought it out. And I argue in the book that that's why I think sports evolved. It's one of the reasons sports evolved. So play is important for all animals. All animals play as children, or at least all mammals and many other animals too. There are only a few species that play as adults. Dogs are one of them. They tend to be domesticated species, by the way. So play is partly important because you learn skills, you develop capacities, you get stronger, you get faster, you get good at throwing a a ball or a spear so it hits a target, which is good for hunting. That's kind of obvious. But I think the other reason that we evolved to play for sports, especially for sports, is to teach us not to be reactively aggressive. As we call that good sportsmanship, for lack of a better term. Not really a gender neutral term, is it? But anyway, so if the other team scores a goal, it's not acceptable to go and punch them, right? You try to score your own goal without fouling them, right? That's why we have things like fouls. Fouls are supposed to be bad, right? So I think that we evolved sports as a species, partly and play, partly to teach each other not to be reactively aggressive, but also to teach each other, in some regards, to be proactively aggressive and to work as a group to achieve an end with a physical purpose. And I think that's the origin of sports. So we often think about sports as being important for exercise. And sure, you can sometimes, but not always, get exercise from sports. But I don't think that's why sports evolved. And you can look at all kinds of sports that humans play, and you realize that they're designed for teaching aggression. I mean, look at American football, right? That's just basically a form of organized, legalized battle, for lack of a better term.
Yes, it is. This is very aggressive. Yes, it's very intense. And I think of boxing as well. It's very, very aggressive and intense. I guess the next question I have here is about evolving to be physically active and for walking. You talk about walking in a big section of your book. And there's a whole, we need 10,000 steps a day, and we need to do that and all these things. So maybe you can I can tee you up here with I think it's in both books, the pendulum of walking, right? I can see the graph in my head in the books of what changed when we moved from walking on 4 legs to 2 legs. I'm reminded of, I think I talked about this a little bit with Jeremy De Silva when I talked to him a couple months ago. Also when he wrote a book about being bipedal and all that. And so just tell us what changed from 4 to 2 legs and why walking is important for us as humans.
Well, 4-legged animals and 2-legged animals both use their legs as pendulums. There's nothing special about the human pendular system of walking in that regard. What is special about human walking is that we do so much of it, and we balance our trunks upright on top of it, thus freeing our arms to do other things. But the reason we started walking, and I do not agree with Jeremy Silva, and I, who's a lovely guy, but we don't agree on this. But there's really no good explanation for why we started to walk, other than the fact that when our ape ancestors walked on 4 legs, they spent much more energy than we do. So if you put an oxygen mask on a chimpanzee and measure its oxygen while walking, they spend twice as much energy to move the same distance for the same body mass. And that's because they're knuckle walkers that are kind of good at both. Also, they have to climb trees. It's really important if you're a chimpanzee. Right. But we evolved from a creature that looked very much like a chimpanzee, and we kind of couldn't just go back to being a normal quadruped. And as forests started disappearing and food sources started being further and further to get to, and so walking upright was a way to save energy. Remember, all that matters is how much energy you can plow into reproduction. If you can save half as much energy walking to get your food, in a context like that, that's going to be very useful. And then later on, we invented tools and doing all kinds of wonderful things. But all that came later, all of that. But that's really all that's sort of special about human walking, is that we just, do it on 2 legs as opposed to 4 legs. But the basic mechanics of walking is actually not that different between a human and a quadruped. And I think we make too much of that. There some changes had to happen. We had to evolve different kinds of pelvises. We had to develop a curve in our lower back. There was some important selection to that. But biomechanically, it's not a big deal. That what really became exciting for human beings is the other thing that happened, which people often forget about, like that book you just mentioned doesn't talk about running. Yeah. But running is not fast walking. Walking uses a pendular gait, but when you run, you use your legs like springs, like a pogo stick. You're storing up and releasing elastic energy, and you're using energy in a completely different way when you're running. And that requires a whole suite of adaptations that you don't need for walking, and that walking animals don't have, like springs in your legs and different kinds of sensory systems to prevent you from pitching forward, and like a big gluteus maximus, which is, biggest muscle in the human body, is basically quiescent during walk. It does nothing in walking, but it's essential for running. And I could go on. There are all kinds of other features, like the spring in your arch and the arch in your foot, which is a spring, and short toes, and etc. And so we evolved first to walk, and walking is really important in humans, and still is, right? So your average hunter-gatherer walks 9 to 15 kilometers a day, which is every day, no weekends, no retirement, So to put that into perspective, your average hunter-gatherer walks from California to New York every year.
Wow.
Every year, their whole life, right? Often carrying things, by the way. And then we also evolved occasionally to run. I mean, not all the time. And there's an amazing suite of adaptations that we have that don't make any sense for any other function other than running. There's no other explanation for them, like our big gluteus maximus or elongated Achilles tendons and so on. So that's also became an important thing in human evolution. And walking, and the reason it matters is that the most fundamental form of moderate physical activity is walking. And we evolved to do a lot of it. And if you don't do it, that means you're not getting moderate physical activity. But we also, as we just talked earlier, it's also important to do vigorous physical activity, right? And what's the most fundamental form of vigorous physical activity? Well, it's running, right? It wasn't swimming, and it wasn't, stairmastering, and it wasn't, exercycling or whatever, or rowing. It was running, right? So running is what we evolved to do, and you don't need to do a lot of it, but occasionally a little running gets your heart rate up and causes all kinds of other stresses. And of course, today we can supplement running with or substitute running with other kinds of vigorous physical activity. But some vigorous physical activity is mighty darn good for us, and there's a reason for it because we evolved to do it.
The other thing I wanted to follow up there is about this 10,000 steps thing, right? How again people want to have this kind of like flat, you have to do this or have to do this, number a day or things like that, and maybe people have, like you said earlier, right? There's an economy of this stuff, right? You have Fitbits and watches and all these things tracking your steps. How many do you have? I mean, is the general idea here that you should be active every day? A little bit, maybe some more than other days, or but is this 10,000 steps thing just kind of a myth, or what's your idea on this?
Remember that the reason I entitled the book Exercise is that we make people exercised about exercise, and one of the ways we do that is we commercialize it and we medicalize it, right? And 10,000 steps a day is a prescription, right? That's medicalized. That's also been sold effectively commercially. But the idea that there is a exercise prescription that's best for you is just ridiculous. It's fiddle faddle, right? It's made up, right? There's no evidence for that. It turns out that 10,000 steps a day, like the story of that came from a Japanese company. They invented this pedometer around the time of the Olympics when they were held in Tokyo in 1964, and they wanted 10,000 turns out to be an auspicious number, and they thought, well, that's a good name for this pedometer, and they called it the 10,000 steps pedometer, and it kind of stuck. Now it turns out that an average female hunter-gatherer might actually take about 10,000 steps a day. It's not a completely unreasonable number, but that doesn't mean that you should take 10,000 steps a day. The answer, if you actually look at the data, if you're physically inactive and you do a little bit more physical activity, you're going to benefit, right? So if you're doing nothing, doing a few thousand steps more a day is fantastic. And if you can get up to yet more, you're going to get more benefit, and eventually the benefits tail off, and you're not going to get any additional benefit, right? It's how much you should do depends on who you are and what you care about and what your fitness level is, and whether you're worried about Alzheimer's or cardiovascular disease or trying to lose weight or the list is long, right? And are you living in a suburb, or are you living in a city, and are you wealthy? You can go to a gym, or do you have to do this on your own in your living room and during a lockdown in a pandemic? And there's the idea that there's a prescription is actually a dreadful notion that we've continued to push, because again, we've commercialized and medicalized exercise, and it doesn't work that way. And so really, if there's any one argument of the book, is that we have to stop thinking about physical activity and exercise from this solely commercialized, medicalized perspective. Now, there's nothing wrong with prescribing exercise. There's nothing wrong with selling exercise, but it doesn't work for most people. And the way we do it often backfires.
Yeah, kind of on that, there's people that will run a lot, right? Or they'll exercise a lot, right? And there are negative things to that as well, right? I mean, you can hurt your joints in your knees, your ankles.
Sure, everything has trade-offs, and running is going to be one of them. So no exercise, no physical activity is going to be injury-free, right?
Sure.
There's always a risk of injury. Although you're going to be more likely to injure yourself if you're a weekend warrior and you suddenly, you're not very fit and all of a sudden you decide to go run a marathon or run 10 miles. Of course you're going to hurt yourself. Just as if I were to try to bench press 500 pounds, I will definitely hurt myself, right? I can't do that, right? So, we're evolved to do all kinds of different things, but there's no question that some degree of vigorous physical activity has enormous benefits. And you don't need to do a huge amount of it to get a small amount of benefit. And that's really the basis of HIIT, right? High intensity interval training. Nobody was solely fit from just doing HIIT, but doing a little bit every once in a while, revving your body up, getting yourself up to your aerobic threshold, so you're really having to work hard for even just short periods of time, has been shown over and over and over again in tons of studies to yield substantial benefits. But of course, you got to be careful when you do it. If you're out of shape and you're really unfit and you have heart troubles, you could hurt yourself. So you got to be careful about doing it and consult a physician before you're doing it. But there's no question that if you can do it, you should do it if you can.
Mm-hmm. Yeah. I wanted to just ask real quick before we go to the last bit of the book, which is on this active grandmother hypothesis. So I've talked to a few people about the grandmother hypothesis, and it's very interesting.
So I call it the active grandparent hypothesis.
Okay. Yeah.
Tell us grandmothers, how you mean grandfathers too, right?
Yeah. How do you understand the active component of it? Just to elaborate on that bit of it.
Well, look, humans evolved to be physically active, and we evolved to be physically active as we age. When you're, one of the reasons, that what the grandmother hypothesis argues, and grandmother hypothesis is only one of several arguments out there about why humans evolved to live long. Right. But humans are unusual in that we have a very long lifespan in which we typically live after we stop reproducing. Now, of course, that makes more sense for females than males, but males also tend to live long too, right? But we didn't evolve to live long just to kind of hang out and, sit in camp and, read the paper. We evolved to be physically active and forage and hunt and do stuff and provide resources for our children and our grandchildren. And guess what? All that physical activity actually promotes health and keeps us from senescing rapidly. And so what we're arguing in the active grandparent hypothesis is that we evolved to live long, not just to be physically inactive, but to be physically active. And that physical activity also helps us live long. Because remember, physical activity extends what we call health span. We spend too much time talking about lifespan. Lifespan is how long you live, when you die, but health span is how long you live in a healthy state, right? Without chronic disease and other sort of major ailments that prevent you from doing what you want to do. The average American today has a lifespan of 79. But the average American's health span today is 63. So we spend, on average, 16 years in a pretty chronic, debilitated state. That's on average. Of course, there's a lot of variation. And one of the things that is most important in extending health span is, guess what? Physical activity, right? Exercise. And before the invention of modern medicine, with all kinds of pills and surgeries and whatever, your lifespan equaled your health span. People, once their health span ended, they died quickly because they couldn't, there was nothing to keep them alive, right? They would die from those diseases. So what we're arguing is that the various ways in which physical activity extends health span is actually part of the human system to extend lifespan. And if we didn't have modern medicine today, people who are less physically active would pay a much more substantial price than they actually now do. And I'm not saying we shouldn't treat them, we should. But if you want to prevent illness as you get older, if you want to prevent heart disease, hypertension, if you want to prevent diabetes, if you want to prevent cancer, if you want to prevent Alzheimer's, all of these are most effectively prevented by being physically active. And we would save gazillions of dollars, well, trillions of dollars in medical costs, not to mention, help people live longer and more fruitful and healthy lives if more people were physically active. Of course, I'm not saying that diet isn't important. Of course, diet's important. Stress is also important. I'm not negating the importance of those other factors, but physical activity is also part of one of them. So the bottom line is that we evolved physical activity as we got, as we get older, physical activity doesn't become less important, actually becomes more important for health. And I argue that has actually has an evolutionary basis.
Yeah, no,
that's the active grandparent hypothesis.
Yeah, I think that's really, really, really key important point is, many people talk about, quality of life and how do we have, a qualitatively better life as we get older. And I think that's a really important point. Yeah, you can live to be 85, but if you're, in a chair and you have an oxygen tank and a cane, I mean, obviously there's other, things that can happen to someone, accidents, things like that. But, it's important to have good quality of life, as long as we can.
And an important point, it's like, I can't emphasize this too much, is that you don't need to do a huge amount of physical activity to decrease your vulnerability to disease as you age, to decrease the rate of senescence. 150 minutes a week of moderate to vigorous physical activity, 21 minutes a day, which, by the way, only about 20% of Americans get, right? That can have substantially reduce your vulnerability to a wide range of these diseases and increase your health span substantially. And you don't need to run marathons or swim the English Channel or do triathlons or whatever. Just going for brisk walk every once in a while. Maybe doing a little vigorous activity every once in a while. Doing push-ups. In the morning when you making your coffee or whatever. All of these things can add up, and you don't need to do vast quantities at high intensities in order to get the benefits. Small amounts. But the fact of the matter is that we have removed even the small amounts from our life in so many countless ways. I mean, I can't tell you how many in my building where I work. My department's on the 5th floor, and everybody takes the elevator up to the 5th floor, and I want to take the elevator too, believe me. And if I weren't writing about this stuff, I would take it, but I would be called a hypocrite. So I have to take the stairs, but I benefit from taking the stairs. And my colleagues and friends would benefit if they took the stairs more, but they have to overcome an instinct. But it doesn't take a lot of stair climbing to get the benefit. It's actually pretty trivial. You just, climb the stairs a few times a day, and you're going to get a lot of physical activity benefit that will help you.
Yeah. One of the last questions I have here is about the social elements of exercise. You talk about how exercising or being active with other people together, what are some of the additive benefits of exercising with others or in a social context? I mean, obviously this has a big, area within our society as well. People do big yoga classes and spin cycle and all these things like that. Why do we want to work out or exercise or be active with other people, and how is that important or helpful?
Well, remember what I said earlier, right? We evolved to be physically active for 2 reasons and 2 reasons only: when it was necessary or when it was rewarding. And the fact of the matter is, it's no longer necessary, right? We can say it's beneficial, but it's no longer necessary. I don't need to be physically active anymore at all. I could sit in a chair all day long and just press buttons, and I'd be fine. Never get my heart rate up. So how else are you going to make help people be physically activity so that it doesn't suck and they're not going to avoid it and run away from it? Well, you have to make it fun. And one of the ways to make it fun, one of the most effective ways to make it fun, is to make it social, right? If you think about dancing. I mean, who doesn't like dancing? Well, there are a few people who don't like dancing, but they're kind of, they're inhibited and that's just like a problem with them, and they should, whatever. But dancing is, no, people don't think of dancing as exercise, but it is, right? It's physical activity, but we don't think of it as exercise because it's fun, it's rewarding, right? It's social. Of course, if you put on an exercise class and that makes you dance in front of your TV or something, then we call that exercise. But that can still be fun. So, in category after category after category of physical activities that people tend to do and like, and not always call exercise, they tend to be social. Like, this morning I went running with a friend, right? It's disgusting out there. We had a blizzard last weekend. There's slush all over the place. There's snow. It's just a loathsome environment to go running. But my friend invited me, and we met at 8:00 and we went for a run on slushy streets. And you have to be careful not to slip and all that. But I'm really glad I did it, because we had a nice conversation about this, that, and the other. And it was fun to catch up and talk about gossip and, about what's going on in our world and our lives and our kids and our parents and all that sort of stuff. And then I was glad I did it. And it didn't feel like exercise. It was going out for a run with my friend. And there are, countless other examples of that. And when you exercise with other people, you help keep it up, and it helps keep you from quitting, and helps you give you positive reinforcement. And another example, I use the Peloton app, for strength training. I go down to the basement, put on the TV, and there's this guy who does strength training classes. And there he is on the TV in front of me, and it was probably recorded in New York, God knows when. But he's doing the same exercises as I am, and he's offering encouragement and timing, keep it up, keep it up, keep it up, don't give it up, etc. And it works. If I didn't do it with this guy in front of me, I probably wouldn't do as many planks and push-ups and lunges and all these other crazy things, and it benefits me. It's social in a kind of weird way, but it's still social. It's a kind of modern form of social physical activity.
Yeah, I think. It's definitely. I've worked out with a couple guys, and I play tennis, and I play with a couple guys, and we play tennis, and there's just the social element is. I think you're very right about the rewarding element. The way you end the book, I think, is really, really, really nice. It's a very nice way to end it. You say, make exercise necessary and fun, do mostly cardio, but also some weights. Some is better than none, and keep it up as you age. And I think that's it's a really nice, summary of the book and in many ways of what you've been saying here in the conversation. And so, is there anything else you could add to that, right? That's really the summary, right? That's it. We should exercise definitely as we get older. But is there anything else on that kind of summary that you want to add about exercising the human body?
Well, it was a kind of a tip of the hat to Michael Pollan, but the sad fact of the matter is that those last four sentences, probably last four lines, everybody on the planet already knows, right? It's just that we've discombobulated ourselves in so many ways in this modern world, and made people so, again, exercised about exercise, that we've kind of forgotten some of these basic truths. And I think that the argument I want to make really is that our bodies weren't designed, they weren't engineered, and they evolved, and they certainly didn't evolve for the kinds of environments that we live in today. And if we want to understand how to better use our bodies, we can't just use a medical perspective, and we can't just use it in sort of commercial perspective. We need the lenses of evolution, and we need the lenses of anthropology to help us understand ourselves and our bodies and why they work the way they do. And also, when you do that, it gives you some alternative perspectives on how to improve our things. Because the fact of the matter is, we're doing a terrible job helping people be physically active. And we're paying a huge price. So one example, because we're in the middle of a pandemic right now, is COVID, right? So one of the ways in which physical activity helps us is by actually charging our immune system. And there's an idea out there that if you exercise too much, it's bad for your immune system. There's actually not much data to support that. In fact, what people really need to know is that if you get a moderate level of physical activity, you actually upregulate your immune system in profound ways that actually help with COVID. So the first line of defense in COVID is actually our cytotoxic T cells and our natural killer cells. Those are the cells our immune system produce that kill viruses. And if you get infection in your lungs or in your respiratory tract, those cells are the ones that are going to keep you from having a big viral load. Guess what? Physical activity upregulates them. Physical activity also improves your production of antibodies and their antibody response. Physical activity also affects by turning on your muscles turn on the anti-inflammatories that regulate inflammation. And what kills people in COVID is actually an oversensitized immune system. So guess what? When people measured so they did this in California at the Kaiser Permanente health system, which unlike many health systems has physical activity as a vital sign. So when you go into the doctor's office and they measure your health, your temperature and your blood pressure and your cholesterol, most places don't ask you how much you exercise. Kaiser does. And so they used this big database and looked at who gets more than 150 minutes a week, which is just a simple benchmark for just minimum levels of physical activity. Who gets 150 minutes a week, and how much more likely, after you correct it for every other variable you can consider, body weight, smoking, alcohol, age, you name it, right? They corrected for all these other covariates, diabetes, and found that individuals, all other things being held equal, people who got 150 minutes a week of physical activity were 2.5 times less likely to die from COVID.
Wow.
2.5. That's ridiculous.
Wow, that's
Why this didn't get more press is a good example of how we are biased against exercise and physical activity. People don't want to hear about it. They were also 1.7 times less likely to get into the hospital. When you get your immune, your vaccine, exercising that day will improve your response to the vaccine, especially as you get older.
Is this why I don't know if you know this, I see that when a lot of athletes have got COVID, they bounce back super quickly. 10 days they're playing the next game or whatever. I don't know if everyone's different, but is that just because their bodies are so they exercise a lot, they practice every day, they play matches or games or whatever? Is that part of the reason why? Or
well, we know that people who are physically active bounce back faster from respiratory infections than people who aren't, for just these reasons. I don't know if you have to be an athlete to get there.
Sure.
Somebody who just exercises regularly is just much less vulnerable, even if they have diabetes, right? Even if they are obese, even if they're got other issues, they're still better off. And the reason is that we tend to think about exercise as medicine, right? Exercise, that's the trademarked slogan of the American College of Sports Medicine. Exercise is medicine, TM. And to some extent it is. It helps you fight disease and all that. But even more importantly, exercise, i.e. physical activity, is just part of our natural environment for millions of years. And our bodies never evolved to function appropriately without it. So a better way of saying it is that the absence of regular physical activity increases your vulnerability to a wide range of diseases. You can still live a long time, but you're just much more likely to get sick if you don't exercise. And it also increases the rate at which you senesce. Your body senesces more rapidly. Those are not controversial statements. And so we need to figure out ways in this modern world where we've replaced physical activity with machines and technology. If we want to, we only have one life and one body, and you want to use that life as best you can and treat that body as best you can. And if you want to do that effectively, one of the ways, and it's not the only way, diet is important, stress is important, etc. But one of the ways is to get physical activity, and it's not very hard, and you don't need very much, but we need as a society, as a culture, to help promote that, and it should be part. We all have a philosophy. People need a philosophy of life, I think, but they also need a philosophy of their body, and we lack that.
Yeah. Well, that's exactly what you're doing in your book. And I think that's why it's so brilliant. So the most recent book is Exercise, Why Something We Never Evolved to Do is Healthy and Rewarding. Where can people find the book, and where can they find you and your research and all the good places?
Well, the book is now out in paperback, and so they can find it, all the usual sources, including, local bookstores and the big giants online and all that. It's not hard to find.
Yeah. And yourself, where can people find you or find your work? Or
just Google me. I have my lab has a website. It's kind of I need to update it as usual because I don't spend enough time on that kind of stuff. I do not do social media and have no intention of doing social media.
Probably better for it. You're probably better.
It's good. It's good for my mental health. Oh yeah, that's another issue we didn't talk about. We didn't talk about physical activity and mental health, and that's another vastly and seriously under discussed topic. And it's unbelievably important, and it's not a black box. We understand how important physical activity is for preventing depression, treating depression. It's important for anxiety, many other aspects of mood. Again, we treat mental health brutally in this country, and we leave physical activity out of it, and that's another issue that we should not ignore.
Absolutely. Well, look, Dan, this is so much fun. I want to respect your time. So I appreciate you for coming on and talking to us about such a really, really important topic. And just can't say enough thanks.
My pleasure. Thank you.
All right. Thanks.